So lesson 31 on credit cards. This section has been really fun and interesting. We've talked about buying a car, we'll talk about buying a house, we're talking about credit cards. Yeah, it's really neat. Let's see, and then the lesson 33, we tie it all together with the $1 million problem. Can't wait to hear what that one's all about. So we're going to model an exercise to talk about credit cards. You've charged $1,500 for the down payment on your car to a credit card that charges 19.99% annual interest. Technically, I don't think you can do that, but it's all right. We're not going to argue with our mathematical modeling exercise. So you plan to pay a fixed amount towards this debt each month until it's paid off. We denote the balance owed after the nth payment has been made as B sub n. What is the monthly interest rate? Which is I. So monthly interest rate. I have 0.1999 over, oh that's a 9, over 12, which gives me 0.016663. Yep. So that is my monthly interest rate, approximate to 5 decimal places. You have been assigned either the 50 team, the 100 team, or the 150 team, where the number indicates the size of the monthly payment R you wish to make towards your debt. What is your value of R? R is my monthly payment, $50, $100, or $150, depending on what team I assign you to. We're not doing teams. I'm going to work through all the data, and you're going to watch. So remember that you can make any size payment toward a credit card debt as long as it is at least as large as the minimum payment specified by the lender. And that's all in the fine print of your credit card. Your lender calculates the minimum payment as the sum of 1% of the outstanding balance and the total interest that has accrued over the month, or $25, whichever is greater. So your minimum will be $25 or more. Under these stipulations, what is the minimum payment? Is your monthly payment R is least as large as the minimum payment? Yeah, the minimum payment for our example is 1% of $1,500 plus our interest rate of $1,500, which is 39.99. That's our minimum monthly payment of the credit card. So all these this value is greater than the $25 minimum. Cool? Cool. All right, complete the following table to show 6 months of payments. We're actually going to do this 3 times, one at $50, one at $100, and one at $150. Okay, give me a second. Okay, here we see the table filled in. Interest due in dollars. That means I look at my balance times my interest rate, and I get 24.99, so $24.99. So I'm paying that. My payment is $50, so paid to the principal is $25.01, and paid to interest is $24.99. So this is how much I'm paying. This much is going towards the interest, this much is going towards the principal. Then I add those up, and I subtract from my balance. Sorry, I don't add those up and I subtract from my balance. My balance is the original amount minus what I pay to principal. Okay, the interest doesn't go towards the principal because it's interest. 2501. Yep, 1474.99. So this is my new principal, which is right there. Now I take that value, 1474.99, multiply it by my interest rate, and I get how much interest is due. Well, this is how much I'm paying. So 50 minus 24.57 means that this much is going towards the principal, and I need to subtract that. So the previous balance minus how much goes towards principal is my new balance. I take this value, I multiply by my interest rate to get this. This is how much I'm paying every month. Subtract my interest rate, that's going towards principal. Subtract my principal, get my new balance. All right, so 6 months, my balance is now $1,343.54. That means that I've paid in principal 1343.54, a whole whopping $156.46 in 6 months. Principal is, I just added these together, 156.46. How much have I paid in interest? This one's harder to add. 1 second. This is how my videos get long. I'm killing time. I've paid $143 in interest. Okay, this money's not coming back. It didn't go towards the down payment in your car. It's money that you're paying straight to the bank just for the opportunity to use the money that they lent you. Okay, it's crazy. All right, moving on. I'm going to show you the $100 per month. So here we're paying $100 per month. So $50 per month, the amount of interest that we paid was $143 and some change. Oh gosh. $143 and some change. The interest we're paying here is $130.77, and the amount of principal we've paid down is $469.23. So this is already much better. Okay, you're paying down the principal a lot faster. You're paying less in interest rates because you're paying $100 per month versus $50 per month. All right, moving on. Okay, here, sorry. We're paying $150 per month. Let's add up our interest. So here we've paid $118 in interest, which is less than the $143 from the first example, or the $130-something. I don't remember what it was. From the second example, okay, much less paying in interest. And we've paid down the balance really well. Okay, we're more than halfway there. Cool. Okay, let's see where this takes us. All right, let's try to come up with a recursive formula. If you remember the how a recursive formula looks, I'm looking for something that has, excuse me, b sub n equals b sub n minus 1 in some math with it. Okay, so I need to figure out, sorry, I had to clear my throat. I have to figure out how to get my new term with the previous term in some math. So let's just look at it. Like my previous term, let's just grab this one, and I'm trying to get to my new term. So this would be b sub n minus 1, and this would be b sub n, right? Well, what math am I doing? I have b sub n equals b sub n minus 1. I'm multiplying this value times my interest rate, right? And that is just giving me my interest in dollars. So let me just grab that, 1374.99 times 0.01666. Yep, that's how I get 22.91, but I really don't want to multiply it by just my interest rate. If I take that 1374.99 and I multiply it by 1 plus my interest rate, let me give you an example. I just did 1374.99 times 1.01666. That gives me 1397.89. Now if I subtract how much I pay each month, I get 1247.89. It's actually 897, so that would be 90. In fact, this would also be 90 if I didn't round it correctly. So there, right there is my B sub n. So I really need to take out my recurring payment. Yay, we did it! We got a recursive formula. I know how much we love doing that. Or maybe you guys love doing that and I'm just the one that it isn't my favorite thing. But we got a recursive formula. And now for the recursive formula. I find that I have the easiest time doing, explicit. I find that I have the easiest time doing the explicit formula if I start sort of seeing my pattern. So let's just look at the pattern. This is what we've been doing, right? And if I did B sub 2, I would have B sub 1, 1 plus I minus R. But really, B sub 1 is B sub O, 1 plus I minus R, 1 plus I minus R, right? I just replaced this value with that equation. All right. All right, I need to distribute that guy. 1 plus I squared minus R, 1 plus I minus R. So that is B sub 2. Okay, let's do it one more time. I know. It'll be all right. B sub 3 equals B sub 2, 1 plus I minus R. Yeah, I'm doing it. You know I am. I have B sub O, 1 plus I squared minus R, 1 plus I minus R. All of that times 1 plus I minus R. Let's go ahead and distribute this. It's going to be awesome. B sub O, 1 plus I cubed, because you're going to see a pattern and it's going to be great. 1 plus I squared. Okay, do you see it? It's pretty cool. Change colors because I'm getting towards the bottom, which is hard to see. So B sub n is going to be B sub O, 1 plus I to the n minus R, 1 plus I to the n minus 1 minus R, 1 plus I to the n minus 2 minus dot, 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 minus R. Cool? Cool. That was hard. Okay, let's try G. Rewrite your formula in part F using R to represent the quantity 1 plus I. Okay, no problem. Sorry, I just hit something on my iPad. B sub n equals B sub O, R to the n, R to the n minus 1, R to the n minus 2. That's a minus. R, well, let's dot, dot, dot it. Dot, 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 minus R. R minus R. Lots of R's. It's all good, though. That right there, let's clean that up a little bit. Okay, see if we can simplify. B sub O, R to the n. It's like born minus R. I factored that out. All right, apply the appropriate formula from lesson 29. So we're going to put this into a formula we can use. So let's start out. I'm just going to recopy from the previous slide so I can see what I'm doing. this is what we did. So I can oh, for goodness sakes, I have to take my watch off. It keeps on touching something in my iPad. So this right here can simplify into 1 minus r to the n over 1 minus r. Cool? Whew. All right. So if we are trying to find the month when our balance is going to get paid off, I'm trying to solve this. Well, our balance is paid off when B sub O equals 0, right? Because we are paying off a credit card, we're paying it off per month. When the left side of the equal sign equals 0, that means we don't have anything else to pay off, right? So this is going to take some math to figure out. But basically we're trying to find when B sub n equals 0. I wrote that wrong. B sub n equals 0. The final payment is less than a full payment so that the debt is not overpaid. And that's how banks work it. The final payment is going to be less than a full payment so that they make sure at the end we haven't overpaid anything. All right, so we're trying to find 0 equals B sub O r to the n minus r over. So I can go ahead and move this to the left side of the equal sign. And then do some math. I'm going to multiply both sides by 1 minus r. And distribute. Okay, I'm trying to get my exponents on the same side of the equal sign so that I can solve for it, because they need to be near each other so I can work some logarithm magic. So I'm going to add this. I hope I'm not doing anything too crazy for you guys. Now I can factor this out. So that gives me r to the n times b to the o 1 minus r plus r equals r. Okay, you see what I did? I factored this out, and I'm left with b o times 1 minus r plus r. Awesome. Now that leaves me with, I'm getting a new slide. I should have written smaller, right? I'm just recopying from the last slide. Alright, now we've solved for r to the n. It's a mess, but we solved for it. Take the log of both sides. So n log r equals log of this mess. Yep, that works. So n equals, you're right, I'm writing the whole thing, over okay, I need this equation to analyze. If I go back and look at the problem, it says find the month when your balance is paid off. I need to analyze this for $50 per month, $100 per month, and $150 per month. So I'm going to get one more new slide. Alright, let's try this. So first I'm going to solve for r equals 50. Log r is 50. I don't need to write r. Over 1,500 was our original amount. 1 minus the interest rate plus big R over log of the interest rate. Okay, hold on. As a little reminder here, R we said was 1 plus I, or 1.01666, right? We replaced that quite a while ago when we just said we're going to use R to represent the quantity 1 plus I. All right, so I'm going to plug this all in. Be right back. I said that once before, I know. So this one gives me 41.92. So the debt was paid off in 42 months, just to be sure, which would be 3.5 years, approximately. All right, I'm going to try R equals 100. Be right back. So this one is 17.40. So we have 18 months. That's pretty awesome. Big difference from 42 months, right? Let's see the awesomeness of R equals 150. Okay, I'll be right back. And this one is 11.03, so just under a year. Okay, sounds like a winner to me if you can afford it. But honestly, I would just not take a loan out for anything that you can't afford. All right, calculate the total amount paid over the life of the debt. How much was paid solely to interest? So for R equals 50, the debt was paid in 41 payments of $50. Hold on, 41 payments of $50. And the last payment because remember we said 42 months. So in the last payment, is the amount B41 with interest. Right? So we have 50 times 41 plus the last payment. If we go back to our recursive formula to see what that last payment would look like, it's 1 plus I times B41. So let's do a little math. 2,050 plus, remember this is R. B41 looks like this. Make sure I get my parentheses straight. So we have 2050 plus 1.01666. Original 1.01666 to the 41st minus, we're doing 50 here, 1 minus R, keep on going back to 1 plus I, so 1.01666 to the 41 over 1 minus 1.01666. Close my parentheses. I actually need to close them twice. All right, I'm going to push pause and crunch those numbers and see what I get. So the total amount paid over the life of the debt for R equals 50 is $2,096.37. So that just means that if I did some subtraction, that is my interest paid. That is money that you just gave to the bank for lending you money. You don't show anything for that. It's just wasted money. They're charging you for the fact that you can't save money for a down payment. I'm going to go ahead and do R equals 100 and R equals 150 and just show you the answers, because because I'm pretty sure you don't want me to do all this math again. So we're doing 17 months, 17 payments of $100. So the last payment was B17, okay? 1 second. So here, there was a total amount paid back to the bank. So our interest that we paid was $240. Not quite as bad, more than half. But still, it's just money that you could have, I don't know, bought a lot of coffee with or something. Okay, how about R equals 150? So R equals 150, we did 11 months, 11 payments of $150, and the last payment was B11 with interest, right? Because the last payment's always smaller. So 150 times 11, 1 plus I to the B11th. So that's not right. 150 times 11 is 1650. 150 times 11, yep. Plus, what are we doing here? R times B sub O, R to the N minus R, 1 minus, R to the N over 1 minus R. Cool. So that is 1650 plus R. Look, you're watching me do the work. I calculated it out. I was just writing it down. Okay, there we go. For this one, we're just doing $154.49 of interest. Okay, not so bad, right? All right, I beg you not to get worried about all the math that was done in between. The problem set is not that difficult. We did a lot of deriving equations, or deriving formulas in this lesson. So don't freak out. Math people enjoy deriving formulas. I like seeing where they all come from. So I went ahead and put it in the lesson. So don't worry, okay? And we'll see you for the problem set.